distance in?
I would say maths.
Maths, okay.
Yes.
Okay. Okay, that's fine. But if there's any concept that you want us to maybe look at or discuss in chemistry, you could just give me a heads
Okay.
up so that, yeah, could arrange for that. Okay, so I've opened the mail finally. Uh, Let me see, what do we have here? Okay, so you sent number question 14, question 15, and then 6 and 8, right?
Yes, sir.
Okay. All right, I'll share my screen now. I don't think I need to download it, so we'll just kick off immediately. Okay, one bit. 1 hour, 2 of use. All right, so we'll do blue today. Yes, yes, yes. Okay. All right, so I'm sharing my screen, entire screen now. All right, so let me know when you can see my screen.
I can see it now.
Okay. All right. So this is the first one I see that you sent today 11 minutes ago. Okay. So it says the nth term of an arithmetic series is Tn equals 52 minus 4n. It says find the values of A and D. Find the values of A and D. And then it says find which term is 0, and then find the sum of the terms which are positive. Okay, so saying find which term is 0. So let's start with the first one. Find the values of A and D. So we know that A is the first term, right?
Yes, sir.
So how do you think we'll go about it to find A?
Mm,
Any
are you going
idea?
to start me with the formula?
Okay, the formula, right?
Yeah,
Cn
yes.
uh, equals, let's check it again. 52 minus 4n. 52, 52 minus 4n. Okay, yes. So now we have the formula. How do you think this formula can help us with the first term and the common difference? Well, let's start with the first term. First things first. The first term. Do you have a clue?
No.
You're not sure?
Um, the
Okay.
first.
So you know the first term. Yeah, you wanted to say something?
Oh no, I was just wondering what the first time was.
Okay. So the first term is going to be equivalent to when n is 1. If you can find T1, think as A. Okay, so if we understand that, let me just write it here so that we have it at the back of our mind that T1 and A are the same thing. So let's find T1. So T1 just means, of course, anywhere you see N, you put 1. And that's the beauty of algebra, where letters represent numbers. So just simple substitution will save the day. So that will be 52, because this one is a constant, so nothing changes. My 2 doesn't look like a 2, so we'll take it out. Okay, so 52 minus 4 times 1. Okay, so let's just know that we substituted 1 for n, and it's a multiplication that's going on there. So 52 minus 4 will give us what?
48.
48, correct. So that means that T1, which is also the first term, is equal to 48. And so we have been able to solve part of the question, at least part of the first um, question under this particular number. Okay, so the next thing we have to do is to find the common difference. Now, to find the common difference, right, that, well, a couple of ways I could think of that we could do it. But I think the easiest one that you would be able to quickly relate to would be to maybe find T2 and then subtract T1 from T2, right?
Oh, yes.
Do you agree with that?
Yes, we solve T1 and T2 and then subtract.
Subtract, yes. You agree with that, right?
Yes, sir.
Okay. So now that we know T1, at least we have gotten to some level. So all we now need to do is to find T2 and do the subtraction. So T2 is going to be the same thing, 52, well, at least the same thing at this point, 52 minus 4 times 2, because n is 2 now. Okay, sorry, I was not. Sometimes trying to draw a curve with this thing can be a bit daunting. Okay, so here we are, 52 minus 4 times 2. That's the same thing as 52 minus 8. So 52 minus 8 will give us what?
44.
44. So apparently it looks like our common difference is going to be negative, because D will be equal to C2 current term minus previous term. So you can just say T2 minus T1, which is minus 4, right?
Yes, sir.
Minus 6, sorry. Minus 6.
Oh, it's
48.
40. For the second one should be 44. The
Oh,
52.
44.
Yes.
Oh, 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 oh. 52. Yeah, that's true. It's minus 10 that would have given me 42. Okay, so that's 44, right?
Yes, sir.
Okay, so let's put 44 there. And then, so that's going to be 48 minus 44. And that would be minus, no, 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 no. I made a mistake there. That should be 44 minus 48,
It's,
not the other way around. 44 minus 48. I think that thing is just because sometimes we just expect positive answers. Okay, so that's minus 4. Okay, so Do you understand it up to this point?
Yes, sir.
Okay, so that's the common difference. So we've solved the first bit. So let's go to the second one, which is find which term is zero. Now, I know you are thinking about a couple of ways you can do this. Keep on subtracting 4 till you get to zero. But we can think of a faster way, which is what I want to do now. And that faster way is to simply ask ourselves, which n will give us Tn equals zero. Okay?
Mm.
So, in other words, the real question is we want to find out what value of n will make Tn to be what? To be
0.
zero. So once we understand that's what is expected, it makes it easier for us. So we're simply going to assign or equate 52 minus 4n, okay? We're going to equate it to 0 and solve for n. That's just it, okay? So that will help us to find what value of n will make this whole thing to be equals to 0. So let's hit the road. So how do you think we're going to take this? How do you think we're going to handle this?
So I was thinking you're going to multiply, like you bring it over and then divide 4n to 52.
Okay. So before we do the division, what should we do first? We should move 4n to the other side, right?
That, yes.
Okay, better. Okay. So let's move 4n to the other side so that it was negative, it will now become positive, and then divide both sides by 4. Okay.
Yes, sir.
And what do we have? 4 into 52, which is that's
Yes.
13, right?
Yes, sir.
Okay. Okay, so that makes it clear. No competition. 13 is the answer. So that means it's the 13th term that will be equals to 0. So n equals 13. Okay. So I'm sure whoever is marking this question would appreciate how we went about doing it. Of course, well, I mean, if you want to see if it will actually be true, I mean, you will see that it is true. That if you subtract 4 about 13 times, you get 0 eventually as you keep on subtracting 4 from the first term, which is 48. It will give you 0 at a point. Okay, so any questions on this one before we move on?
No question.
Okay. All right. So the last one for that question 14 says, find the sum of the terms which are positive. Find the sum of the terms which are positive. Now, let me ask you a question. Now that they said find the sum of the terms which are positive, what do you think is another way of asking that same question?
So are we going to use the S formula?
Yes, we're going to use it. Yeah, we're going to use it. But the question now is this,
Yeah.
you know, this is not like this they just asked us which term will be 0. They didn't say that 0 is the last term. So that
Yes, sir.
means that there's a possibility that you could have equally gotten the 14th term, which would be what? 0 minus 4, which is minus 4. Do you agree with that?
Okay.
Yes. So this kind of term doesn't have any end. You know, there are some terms that are finite and there are some terms that are infinite. This one is an example of an infinite sequence, sorry, a series rather. So let me just so to like make it quite straightforward. The sum of all the positive terms simply means that from 44, sorry, from 48 all the way to the 13th term, which is 0. Those are only terms that will be positive. Because
Okay.
immediately you subtract 4 again, it now becomes negative. So that, in other words, they're trying to tell us to simply find the sum of the first, if you like, 13 terms. Or if you want to exclude the 13th term, which is 0, it will be the sum of the first 12 terms. Anyone you want. Okay, it will still, because anytime you add 0 to anything, it doesn't change it. So, yeah. So you understand my explanation, right?
How is it the 12 terms?
How you say, how is it the 12 terms?
Yeah.
Okay, so the 13th term is 0 now, isn't it?
Yes.
Most people don't consider 0 as a positive term. They just feel like it's a neutral guy. You understand? Meanwhile, all the numbers that came before 0 are positive numbers, isn't it?
Yes, sir.
Starting from 48, 44, and so on and so forth. There will definitely be positive numbers until after 0. Then you now start having -4, -8, -12, etc.
Okay.
So you get the gist now, right?
Okay, yes.
Okay. So we're simply going to find S12 so that we just stick with um, what majority consider as positive. So maybe maybe okay, let me just see an
Yeah,
explanation.
okay.
Um, find some of first two terms because after after 12,
Yeah.
sorry, some keys on my keyboard are acting up, so I needed to use my alt keyboard, which is 0, 0. After that, have negative terms, e.g. -4, -8. I can just put etc. Okay. Okay, I just thought to put that explanation there. I guess when you screenshot it, it would, you'd see it as part of what you have as a note. Okay. All right. So they just restored our lights. Just give me a minute. Let me connect my. All right. Can you hear me now?
Yeah, can you?
Excellent. Okay. So let's move on. Where was I? Okay. So you understood what I typed here, right?
Yes.
Okay. Good. 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 Okay.
So let's move to find what S12 is. So uh, remind me of the formula. Let's see if you remember. S12 will be given by what?
That would be 12 over 2.
Did you say 2 over 2 or 12 over 2? Which
12,
one?
12, 12 over 2.
Okay, 12 over 2. Thank you. So next, after 12 over 2, what do we have? I'll put
Bracket
that square.
2
Okay, bracket 2. Yeah.
and bracket 1.
Why 1?
It's because of the formula.
The formula says 2A, right? So A
Oh, yeah,
is what?
2A. So
Uh-huh,
A is 48.
uh-huh.
Yes.
48, isn't it?
Yes.
Uh-huh. Okay. Because I was about to ask you how you got 1. Okay. All right. Yeah, go ahead.
Plus,
Plus.
that would be 12 bracket 12.
Thank you. 12 minus 1, isn't it?
Yes.
Okay. All right. And then what's
And
our
40, 44.
decision? No.
D is a minus 4.
Thank you, minus 4. So and because of that minus 4, I'm going to put it in bracket
Okay.
and again, so that when we want to deal with it now, we'll not see it manifesting itself and changing whatever needs to be changed. But minus is quite powerful in mathematics. Okay, so yeah, so everything is just 2. 12 over 2 is 6. In there, I have 2 times 48. That is 96, right?
Yes, sir.
Okay. So 96, 12 minus 1 is 11. 11 times minus 44 is minus 4. Sorry, is minus 44. So 96 minus 44 will give us what? Then you can now multiply that by 6. Are you with your calculator today?
Um, That's
Okay. So that
312.
312 is right.
Yes, sir.
Okay. I was about to do the calculation again. Okay. So 312. And that is the sum. So are you doing a screenshot or you would like me to zoom out so that you can see everything? Or should I just continue?
Yeah, I was zoom out so I can screenshot, please.
Okay. Is it okay? Or did I zoom out too much?
Okay.
Is it okay like this?
Okay. Let me screenshot this part.
In short, this one, this is number 14. Yeah, okay, 1 and 2. Then we can now, I'll now scroll down so we can screenshot this.
I've screenshotted it.
Okay. Alright. Okay.
I've screenshotted it.
Okay. Alright. So let's go to the next question, which is what is the next question? Number 15. In an arithmetic series, C3 equals 0 and C8 equals 10. The distance is much. Can't even help us find B with that. But it's fine. We'll still find a way. And now says find the values of A and B. Hence, find Sn. of the series. Okay, so it now says how many terms is interesting. Okay, all right. So let's pick on the first one. It tells us that T3 is 0 and T8 is 10. Okay, so somebody will be wondering how will the term, the series start with 0 and the eighth term? Okay, not even the first term. So take note of that question very well. It's not the first term that is 0. T3 is 0 and T8 is 10. And somebody will now start wondering what exactly could the common difference be? We'll find out. Okay. So I'm sure you already seen that a simultaneous equation is going to play out here, right?
Yes.
There is no way we can escape it. It's just a matter of time before it will play out. Okay. So first things first. For T3, I write it like this. So that we know that it's Mr. T3 that we're doing. For T3, um, the this thing for arithmetic, at least the question has told us it's arithmetic series. So it's going to be A
Plus 2D.
plus 2D, thank you, plus 2D. And then all that is equal to what? 0, isn't it?
Yes.
So the next one is CH, uh, CH is A plus 7D, uh, A plus 7D, which is equal to what? Uh, Okay, so what did you even tell me was your most preferred method for solving simultaneous equations? Elimination, have you?
Yes, elimination.
So let's use your preferred method, which is elimination. And because A is easy to eliminate, let's do a minus. A minus A is 0. 2 minus 7 is minus 5, right?
Yes, sir.
Minus 5 is. And then 0 minus 10 is minus 10. So we'll now divide both sides by what? Minus 5, isn't it?
Yes, sir.
Therefore, G is equal to C. So, interestingly, D is even a positive, um, it's a positive number. It's now that A that we are all looking forward to finding. Uh, C. Okay, so now that we know that D is true, let's substitute in. I didn't even label my equation. Just to show you how much in a hurry I was to find it. Let's call this equation 6. Okay, so let's substitute in equation 1. In equation 1, we'll have that. What do you have? You have that A plus 2B equals 0, right?
Yes.
So it will be A plus 2 times 2, which is 4, equals 0. So what do you think we'll do with this now?
Equals to 0. So we're going to solve it out. So to be A equals to -4. Oh, I think you bring it over to the
Yes,
0.
exactly, to the 0. That's going to make it minus 4, like you said,
Yes.
which is 0 minus 4, which is minus 4. Okay, so we found the A and we found the B. So we have answered question 1. Yes, so that question 1. Yes. Find the values of A and B. Hence, okay, and hence, so we're not done with question 1. Hence, find Sn of the series. So, of course, I'm sure you already have an idea of what Sn of the series is. Because they are close, let me just put a line here. And it's this guy. Okay. So, Sn is given by what? You just recounted the formula.
Yeah,
So,
it goes to
n over 2, right?
yes,
Uh-huh.
brackets
Okay. 2a.
two bracket yeah two wait
Okay. So we just put in the number.
yes. I was thinking you were going to sub it in.
Okay, okay. No, that's fine. That's fine. So 2
You
times minus 4, right?
yes
Okay. Uh-huh. Plus
plus n minus one
n minus 1. That one will have to be part of it. N minus 1. And then
and
uh,
two.
this. Okay. Okay. So let me just put it in bracket like that. So let's now put our square bracket around it. Uh-huh. So let's see. N over 2. Uh-huh. And then what do we have? Minus 8, right?
Yes, sir.
Minus 8 plus 2n minus 2. And it makes it easier now for us. So minus 8. Now you can collect like terms as you are saying here. Minus 8 and minus 2. They'll go together. So that will give us minus 10, isn't it?
Yes, sir.
Uh, So we'll have 2n minus 10. So that gives us 2n minus 10. And of course, I'm sure you can already see what's going to happen here. Uh, is that if you let that n over 2 go in, you will have, or okay, we can just do, let's allow it going. So that will now be 2n over 2. 2n squared, isn't it? Can you see that?
Mm. Okay.
Uh, 2n squared over 2. So minus 10n over 2. So it makes things easy for us. You can see things will cancel out. 2 in 10 is 5. 2 in itself goes to
N
2
squared.
in itself. So I left with what? N
N
squared
squared
minus
equals to five minus five. Sorry.
5. Okay, so there you go. I think that's a simplified formula for our Sn, right?
Yes.
Yeah. So finally done with that first part. What's the next one? It says how many terms of the series must be added so that the sum is 36. So in other words, I'm just trying to ask us, um, when will S end? What is the value of n that will make S end to be what? 36. That's just another way of saying it. Did you understand it like that way?
Yes, sir.
Okay. So my equals to is looking like normal. So now you don't go and think it's mine. Okay. So now that we understand what is expected, all we need to do is to say equate this n squared minus 5n. I like this one. I can see it's a quadratic equation that is going to come out, but at least it's simpler to do that method, that guessing method, and to start doing normal formula. So let me do another one so that because they're all together like that. Okay, so next thing we're going to do is to move 36 over, right?
Mm-hmm.
So that's what we're going to do. We're going to solve n squared minus 5n minus 36. So now, I'm sure you, okay, let me not say I'm sure. Do you remember the method of solving quadratic equations where,
Yeah, two brackets.
yeah, you will guess, yes, exactly, two brackets, and then you will guess what should be in the two brackets.
Mm.
So, what two numbers, when I multiply them, will give me minus 36, and when I add them, will give me minus 5.
Um, 9 and 4.
9 and 4. Okay, 9. 9 and 4. Okay, so now is it, you know, minus 36? Is it that the minus is on 9 or the minus is on 4? Which one is carrying the minus?
The first one should be -9.
Okay, so now there's nothing that is wrong with saying this. So it must not be that the first one is minus 9. We could have,
Plus
um,
4.
yeah, it's still the same thing. Whether the minus 9 came first or the plus 4 came first, it's still the same thing. The important thing is that we know where the minus is. Because let me tell you something. You make a mistake and put the minus on 4 and put the plus on 9. Guess what? There's no way it's going to give you this number when you add them together. Because plus 9 minus 4 is positive 5. Do you
Okay.
understand? So meanwhile, the product part works, but the sum part will not work. So this is the only combination that will give you minus 5. All right, so this now leaves us to, therefore, n equals what?
4.
N equals minus 4
-4. I'm sorry. And then n
or
equals to
what?
9.
Uh-huh. But you know that it's only one of them that is correct, isn't it? Which one do you think is correct?
And the
Now,
9.
so for you, thank you very much. Why? Why is it the one that is correct? We don't have,
Because it's positive.
is it, yes, thank you. It has to be always positive. We don't ever have negative position. It's like saying first and second and third, and then I'm trying to say minus first, minus second. It doesn't work that way because n is always a position thing. So this one cannot be considered. So yes, n is equal to 9. So it is the ninth term that will give us the ninth term for n equals 9. That will give us the sum of 36. Okay. No, let me not put 9. Let me just leave it as first 9. First 9, yeah. Okay. I think it's okay to just say first 9, 10. Okay. All right. Any questions so far?
That's no question. I feel like the problem is that
Oh,
when because I'm not good when it comes to word problems.
oh,
Sometimes I mix it up.
okay. Okay.
But
Okay.
like when the
Okay.
question is just numbers only,
Mm-hmm.
yeah, we
You
get it.
feel you're more comfortable with it, right?
Yes, but if it's like wording, I get confused
Mm-hmm.
sometimes.
Okay. 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 But you know what? And that I understand that. That's perfectly understandable. Eventually, right, you know what will happen as you expose yourself to more of these puzzles. I call them puzzles, really, like word problems, right? As you expose yourself to more of them, you will unconsciously develop a skill for like decoding them, because that's the first thing you need to do. You need to know what's happening in the question, then solving them. So it's one skill to decode it, understand what the question really wants, then get the data out of the question, and then start using the data for it. So, so it's a good thing. Just keep on solving more problems. Sometimes I tell people that thing that looks like it's really big, like a giant, right? Don't run away from it. Just face it. Eventually, you see that it wasn't that big of a deal after all. Okay. So, um, um, maybe at your spare time, just keep on trying and working on questions like this, and I'm sure you'll make a good headway. Okay. So you are good with this one, right?
Yeah, I'm fine with this one.
All right. Okay. So have you taken a screenshot to
Yes,
that?
sir.
Because I want to use this screen for the next one. Let me see what the next one wants to. Okay, the next one is a different question. Next question is coming with its own band of numbers. Okay, so let's go to the next one. Next one is a geometric sequence. All right, so let's handle it. I think I'll just come up here and draw. No? Okay. Let me just that's number what's that? Six. Okay. Six. Alright, what does it say? The end stem of a geometric sequence is given by Cn equals 5n minus Cn. Okay. Cn minus equals what? 5,
N minus 1.
yeah, 5,
Raised to
yeah,
power n minus 1.
uh, 1. Okay. Uh, minus 1. And then the question says what? Uh, of the sequence. This will be straightforward for you now. All you need to do is to do and one, two, dot, 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 five. Yeah. So just want to, you understand? Should I write it down?
It's fine. I understand it like that. I'm looking at the question right now on my
Goodness, are
laptop.
you there?
Hello? I'm here.
Okay. Sorry, goodness, can you hear me now?
Yes, I can hear.
Oh, sorry. I thought you were still there. Okay. Okay. Alright. So, let's, uh, okay. So, C1. what would C1 be?
And 5 to 0. Raised to power 0.
5 raised to the power of 1 minus 1, isn't it?
Yes, that is 0.
Yeah, that's 5 raised to the power 0. And we all know that anything raised to the power 0 is what? Hmm?
0. That'll
Anything
be
raised to the
1.
power 0, that is
1.
1. But if
Yes.
you multiply anything by 0, yes, so that's 1. Okay, so let's go to C2. So C2 is equal to 5 raised to the power of 2 minus 1. 2 minus 1, which is the same thing as 5 raised to the power of 1. And 5 raised to the power of 1 is equal to 5. Okay, C3 is 5 raised to the power of 3 minus 1, which is right.
Right.
Okay, so sure you can get the
Yeah, I
pattern. You
understand.
can see the pattern coming out, right?
Yes, sir.
And then I expect C4 should just confirm that 4 minus 1, which is 3,
125.
oh goodness, can you see my screen?
Yes, sir.
Okay. Sorry about that. Okay, so I'm done with that first bit. It says we should find the common ratio. So I'm sure you can establish all the common ratio. Common ratio is 5. Okay, so you can do R is equal to C2 over C1. Any of the terms over the previous term will give you R. So that's uh, prime over 1, which is prime. Okay, what's the next one? It says find Sn. Which one? Which formula do you think we'll use for this?
The T and formula for the what question?
Hmm?
What question?
The third one,
Oh, S formula. The SN.
Sn. The sum of the first n things. Okay, one number 6. We're doing number 6 now. Yes, yes, Sn. Okay. So do you remember it?
Yes.
Do you
S
remember it?
SN equals to
By
A
this
bracket
guy's on the pen smaller than 1. So
A.
A. Okay, and our A is 1, isn't it?
Yes.
Yeah.
A bracket 1 minus R.
Bracket the common ratio is
Yes. 1 minus R.
raised to the power of n.
Yes.
Is it
Is okay.
hmm? Is it 1 minus or minus? In this case,
Oh, it's A
so don't forget,
brackets.
whenever it's bigger than 1, the R, okay, don't worry, let me put it down for you just so that you will remember it. A bracket R raised to the power of n minus 1 all over R minus 1. Do you
Oh,
remember it now?
is the other way around. Is 1 minus R to the N.
Yes. And when that happens when the common ratio is less than 1. But
Okay,
in
okay.
this case, our common ratio is 5. So because it's bigger than 1, we use this one. Don't forget, this is the only
Okay.
one where the Sn depends on the size of the common ratio. It doesn't happen for arithmetic sequence. Okay,
Okay.
so you know what to do now. Just simplify it, and then your Sn. I think how will your Sn look now if we simplify it? Of course, nothing can really happen much inside that bracket. So you just leave it as 5 raised to the power of n minus 1, and everything is over 4. This one is not like the Sn for the arithmetic series. It's very straightforward. Okay, so what did they say next? Find in the form 4 two brackets. What on earth is that? I still don't know what that is. That's a 5 raised to the power 0 or what? Or 5 raised to the power n. The difference between
Is
the
there
1010 and the 999. Okay, so now if you look at this, the difference hmm, is different. What do you think this person is saying? Maybe we should find what the 1010 will look like, isn't it? Because
yes. Yes.
one the 1010 this person might be quite tricky, but I think we can handle it. We can. So since they are using, let me just put them side by side. Okay. All right. So the 1010 will be C 1000. Let's establish that. Okay. Three 1000. And that would be equal to 5 raised to the power of what?
999.
5 raised to the power of 1000. Okay. Which is the 9999 scenario.
Yes.
So that is uh, 5 raised of 999. Okay. Alright. Okay. Then T999. This guy is gonna be is going to be what? Um, um, 5 raised to the power of 999 minus 1, which is 998. So that's going to be now. So this is where wondering what that question is relating. The difference between those two things. Say 1000 minus 1000 minus 2999. Okay, okay, okay. So, mm, you know what I think? What I'm even looking at is um the, mm, uh, okay. So I want you to just take a look at what I'm going to do now. Right? 5 raised to the power of 999 is the same thing as 5 raised to the power of 1 times 5 raised to the power of 998. Do you agree with that?
Yes, sir.
Okay. Now, that's what I'm going to use now and do this thing. Instead of using this one, I'll use this one. So C1000 is going to be 5, 5 times 5 raised to the power of 998 right, minus 5 raised to the power of 998. Okay, so can you guess what I'm going to do? What I want to basically do is factorize. You know, when you have something uh, common on two sides of either a plus sign or minus sign, and they are multiplying, you can factorize, right?
Yes, sir.
Okay, so that's what I'm going to. I'll just factorize 5 raised to the power of 998, and then open the bracket. I'll be left with 5 minus 1. There we go. Okay, so are you good with the business so far?
Yes, sir.
Alright, so that's going to leave me with 4 into 5 raised to the power of 9. with what they wanted us to do. So, so if you look at it, it looks like that's what you have there, right?
Okay.
Okay. All right. So you want to do a screenshot before we move on, or is there any part you want me to explain again?
Yeah, I'll just do a screenshot.
Okay. Sorry. Let me move up. Let me move it up a bit because it's part of number six. That is not showing. Okay. Can you see it now?
You have screenshot it.
It's still a part. Okay. Okay. All right. So let's do the last one. Okay. It says three numbers are arithmetic sequence. Their sum is 27 and their product is 704. Find the two numbers if the sequence is in. So they've given us some ideas about what it is and tells us that numbers are in a sequence. So if they are in a sequence, not just any type of sequence, but an arithmetic sequence, then there are some decisions, there are some quick conclusions we can come to. Uh, their sum is 27. Okay, so um, they didn't tell us that the first term, from the first term, second term, third term, but um, x, so let me just start with this x, comma, x plus b, yeah, comma, x plus 2b. Okay, so I hope you understand why I'm using x because we can't. I don't want to think that is the first three terms. They didn't tell us the first three terms. They just said three terms, but we know that there's a common difference between them. So that's why I could come to this conclusion. The three terms should look like this: x plus b, and x plus 2b. Okay.
Okay.
Um, what next? They said that their sum is 27. So their sum, the next decision we're going to conclusion rather will come to is that their sum is equal to 27. So that's going to be x plus x plus b plus x plus 2b is equal to 27 equals 27. So, so what next? We'll now collect like from x is 3x, 3x plus 3b. It can also be b plus 2b is equal to 27. I'm sure you can see something coming out here, right?
Yes.
3x plus 3b. So if you factorize the 3, or if you divide both sides by 3, you'll see that
Yes.
x plus b is equal to 9. You agree with that?
Yes, sir.
Yeah. I'm going to take it step by step, but I think it's something that you can, somehow see. X plus 3 equals 9. So we can say therefore x plus b equals 9. Okay, so uh, that's one quick decision we've been able to make. What's next? They told us that their product is 704. 704. Now, hmm, this product on, and then uh, I hope it's not going to look too complex. So that, okay. So before we even go to that product, I think there's something we can see here. If x plus b is 9, um, can't we make some decisions so far? So we already know that one of them is 9. The middle one is 9. Okay. So the product will be x times x plus b. I can see something coming out already. Okay. And then x plus 2b. X plus 2b. Okay. So can you see something there? You
Yes.
remember we just concluded on this that x plus b equals 9. So anywhere we see x plus b, we are free to put 9 to give us 9x. I've replaced that x plus b with 9. So, so 9x times x plus 2b. Thank God, that made it simpler for us. But I'm still looking like, what are we going to do with x to the power of 3? That's not the kind of equation we've solved before. But it's not complex anymore. Taking out that hard part. So that's going to be 9x squared, right? Plus 18b plus 18b equals what? Equals, is it 207? 704. Okay, 704. Hmm, 704. Okay, so, ah, in fact, where we need to think. Okay, so what do you think we can do here?
Mm,
There's one, if you, okay, yeah, go ahead. What do you think we can do here? Because we're having two unknowns. What do you think we should do?
are we, I was thinking about, but they don't have the same sign. So
Okay, okay, okay.
are we going to
What,
uh,
yeah, substitution, right?
yes,
Do we do a substitution? Okay.
but they both
So,
have different
so
numbers.
if I'm
So
going to do any substitution, yes, about this point, we can see, see this place, this step, very, very important step. So we can use this step again and and do some tricks here. So we can see that, conclude that g equals 9 minus 10. So anywhere we see g, we can just put 9 minus x, and that would make this equation look like this. 9x
okay.
squared plus 18. Now you cannot see, the whole equation will be in terms of x. 18 into 9 minus x. And then um, equals 704. So this thing will give us a quadratic equation, but I'm sure we'll be able to solve it maybe using Almighty formula or something simpler. Okay, so help me with 18 times 9. But that's what I'm going
Mm,
to be having now.
162.
18 times 9 will give me what?
162.
1, 162. Okay. So that's plus 162 minus 18x, okay, equals 704. Now, you know what we're going to do? Bring the 704, or in fact, let me just do it straight up. Minus 704 equals 0. So you now collect like 10. 162 minus 704 will give us what?
542.
542, right?
Yes.
So I'm going to the negative. So this is how it will now look. Minus 18x. Now, please help me check that 542. Is it divisible by 9?
Mm-hmm.
Divided by
No,
9, let's see.
no, it's not.
No, it's not. Oh, not good. Okay, let's try if it's divisible by 3. Let's see. Something that can break it down a bit for us.
500. Okay.
Mhm.
It's not.
It is or it's not.
It's not.
Hmm. Okay. Well, no problem. But we are sure of the number so that we are working with the correct thing. Let's since it's looking like this now, let's just use our micro formula. Um, so just get your calculator ready. Is equal to minus uh, plus so that plus or minus square root of b squared minus 4ac squared minus 4ac or times 9 times 9 times 540. Right, that's everything to b number. I hope this is able to solve the thing. Okay. This is really, hmm. Okay. All this divided by 2 a 2.9. Okay. So, this minus and this um, minus 4 times minus 542 will become positive. So just multiply 4 times 9 times 542. What do you have?
For
4 times 9 times 542. Then, or are you trying to do everything together?
19,000. Oh, okay. Let me do everything together.
Did you say? Uh-huh. And then you can, if you can find the square root at one.
It's giving 3 plus square root 551 over 3.
Hmm? 551 over 3.
Yes, 3 plus
How do we
5.
get it? Okay, wait, wait, wait. That's looking strange. Okay. Uh, okay, let's see. If you did only the what is under the denominator, under the square root sign, what would you have got? 18 squared, that's this bit. 18 squared minus 4 times 9 times minus 540, which is as good as 18 squared plus. Yeah, what would you get?
Oh, okay, wait, let me. It's a square minus 4.
Don't do it as minus again because we know it will become plus. So you can just
Uh,
say 4 times 540. So it will be plus.
oh, okay. 830.
830, okay?
Yes.
Okay, 830. Okay, so what's the square root of 830?
Mm, that's like 28.08.
Yes, mm, okay. So that's 18 plus minus 28.08. Ah, but this thing was looking like it would be a whole number. Me, I was expecting it to be a whole number kind of question, not decimal. I, I hope there's nothing that we miss here. Not good. It's supposed to be. Ah, that's good. Oh my goodness. I think something. I think something that I missed here. Ah, I've seen a mistake I made. Oh boy. Okay. That's fine. It's okay. At least I've been able to spot where the mistake. Okay. So, um, I'm going to back up a bit here. Let me see if I can fix it. Okay. This where we had 9x into bracket x plus 2d. It was supposed to be, the x was supposed to, also be at the back there. So that was what I missed out. Okay. Ah, okay. Ah, okay. So let's see. Let me go to this. Um, that's the basic easy. Um, sorry for that mistake. So I think I just okay. So can you say the mistake I made? Where I missed out, I didn't the X into consideration. Can you see the fact?
Yeah, I can see it.
Okay, so let's see how things will turn out if that plays out well. 9x squared plus
162.
yes, 18 times 9. What did you get?
One. Oh,
162. Sorry, I didn't hear you. Was it 152 you said?
162. 162.
Okay, 162. Okay. All right. Yeah. Okay. 162. Okay. So let me not forget the x again. And then 18x squared. Okay. Um, okay. Um, oh, so that's going to be 9 minus 9, 162, 161 minus 9 of 2, minus 104. All this equals 0. Okay, okay, so let's see. 704. So you try, let's see if it's divisible by 9. 9, 62,
It doesn't.
11. Okay, okay, so um, how about by 3? 3 and 7, 2, no, no,
Doesn't.
9, no. Okay, okay, you know what? So that, let me see. I will, I know there is just one bit left. Wait, I think I might be able to figure it out if I take a look at it again myself. I should be able to figure it out. So like it's, and it's really one that is different, it's one second, okay, you know what? I will, let me solve this, right? I'll just try and solve it again. But I'm thinking of using a different method. It may not be this x plus b, x plus 2b. I'm thinking of using a different method. Uh, that will make it look simpler for us. And let me solve it. I can send it. Have you tried to reach out to me on WhatsApp?
Oh yeah, I don't know how it works. I think I have to add your number, but like I'll have to try again.
Okay, okay. Or did you? Okay,
I'll
oh yeah,
try to add it to contact.
if you can try to add it, okay, all right. Or maybe I'll just send it to you as an attachment as a reply to your another. So I'll start it again, but this time I'm not going to use this x plus b x plus c. I'll use a different method. I'll use x minus b x and then x plus b. That one will make it easier. As I'm going to start it again now.
Did you get my notification
I should
from
I should reply.
WhatsApp?
Is that?
Because I just did you get the notification from
Oh, okay.
WhatsApp? I sent an
Yeah.
hello.
All right. So 2020. Okay. Okay. You know what? Maybe I'll just send it to you. I'll send it to your mail. Or
Okay,
okay, there are
I'll
still
check
messages
my mail.
coming in. Okay. So let me try adding your own number from my end. Let's see if that works.
Should I set my number?
Yes, yes, yes. Send it. I think check. Oh, okay, okay. I've seen it. I've seen it. I've seen it. Don't worry. I've seen it. I've
Okay.
seen it. And it's just plus 353, right?
Yes.
That's okay. That's how it's going to be. Okay. All right. So I'll send it to you. Um,
Okay.
yeah, I'll send it to you on WhatsApp. So I don't want to keep you too long, but now I'm done at the same time. Want to also maximize my battery power and see the light again. Okay. All right. So we'll meet on Thursday, right? That'll be
Yes,
our
sir.
next class. Mhm. Okay. So is there anyone that you needed to screenshot of that you've not done? I think it was just this last one, right?
Yes, sir. It was just the last one,
I
yeah.
think that was it.
It
That
was
was
four of them.
okay. Okay. Yeah. All right. Okay. So we meet on Thursday, 6:30 again. Okay. Trust everything will be okay. All right. So have a good night. Night.
I need to say thank you, sir.
So that's it. That's it. That's it. I'm gonna do that.